Hello everyone, welcome back to the channel. So today in this video, we are going to talk about another Kubernetes component, that is job and cron job. Okay, these two components are very useful. So let's first understand what it is and how to use it, and we'll also see practically how we can create a job and cron job, right? So earlier in our videos or in this Kubernetes series, we have talked about multiple objects like deployment, a Daemonsets, stateful set, right? So all these objects are, what they are doing is they are trying to keep our application up and running all the time. Okay, they are kind of working as a controller, and if our pod is running and due to some reason if it has got stopped, those controllers are helping to basically recreate those and keeping our application up and running all the time. So that's perfectly fine for the application which we want to keep it running all the time, right? But then we may have some requirement, like for example, a backup job. Okay, so we may have a requirement about a backup job. Let's say we want to take a backup of some XYZ application, and that backup process, if you see, or a backup application, if you see, that's not a long running application. Maybe it will just take a backup and we are done. We don't need to keep that application running all the time, right? So there is no point in sorry, there is no point in running a backup application by using a deployment or a Daemonset or a stateful set, because we don't want to keep running our backup application all the time. Instead, we just wanted to run it, and once a backup is completed, we just wanted to terminate that pod, right? So that's where Kubernetes provides a component called as a job. Okay, so we have a job component. What it does, as soon as we create a job, under that job, pod gets created. Okay, and this pod is nothing but, let's say for example, your a backup application image can be inside it. Okay, so what will happen, as soon as pod gets created, a backup application will run. It will, as per definition, it will go and take a backup. And once backup is done, your pod will come into the completed state. And once that is in a completed state, this job controller will not do anything. Okay, so, or even apart from backup application, let's say you have any cleanup job. Okay, or you want to run any batch processing, right? So for this kind of use cases, you can run this applications by using a job. So that job will basically create a pod, and that pod will run for a specific task. Once that task is done, your pod will be in a completed state, and that's it. Okay, so that's how the job would be useful in Kubernetes. Okay, so this job component or a job controller is doing that. Okay, now let's say if you want to run this job on a periodic basis, like for example, let's say you want to do a backup every day, 11 p.m., right? So that's where Kubernetes provides another object called as a cron job. Okay, so cron job is nothing but basically inside that we just define a schedule. Like let's say I want to run a job at 11 p.m. daily basis. So what happens at every day, 11 p.m., under this cron job, a job will get created. Under this job, pod will get created, which will go and run the backup, and we are done. Once that is done, we are done. So again, on the next day at 11 p.m., okay, what will happen? Another job will get created. Under that job, another pod will get created, and we are done. Okay, that will run the backup application. So this is something will keep happening. So this cron job will help us to run a job on a periodic basis. Okay, so I hope everyone understood the job and cron job as a conceptually. Now let's go ahead and see this practically. Okay, so I have a Kubernetes cluster created. Okay, you can see here I have one master node and two worker node. I have created this Kubernetes cluster by using a kind utility. So let's create a job. So what I'll do, I'll just use an imperative command to create this job.yaml, and then I'll walk you through that job.yaml. Okay, so how we create it? Very simple. kubectl create job. Let's say job name is my job, and then basically here we are providing an image. So now we don't have exactly the backup application image available. So what I'm going to do is I'm going to use an Ubuntu image, and inside that Ubuntu image, I'm going to run some small script. Okay, for that, let me just create an YAML quickly. So -" dry run is equal to client. that will give me the output in the YAML format. And then I'll just pass the command. So when sh -c, and then I just want it to run sleep for 10 seconds. Okay, so this is nothing but you can say I'm running the sleep 10 that as a script. Okay, you can replace that with your actual backup script. Okay, and then I'm redirecting it to the, let's say, job.yaml. Okay, so let's open the job.yaml. So this is how typically your job.yaml look like. So as earlier mentioned, you'll have a top 4 attributes here like API version, kind of job. Under metadata, we can have a name, and then under spec, we can have actual specification. So this template is nothing but used by the pod that it gets run under this job. Okay, and here you can see we are using this image, and inside this image, we are running the sleep10 command. Okay, and then here under spec, we can define some specification about jobs, like how many times you want to run the job, whether you want to run it parallelly or sequentially, right? What would be the timeout? Like, I'll just show you some attributes. So how you can get the attributes related to job. So it's very simple. We can just use kubectl explain command. Kubectl explain job.spec. That will give us the specification about job. So we have some attributes that we should discuss about the job. So first one is about active deadline second. So what is the use of active deadline second? So usually, let's take an example of a backup job, right? So active deadline second specifies the duration in second related to the start time that the job may be continuously active before the system tries to terminate it. So basically, active deadline second, we use it. For example, let's say your job takes 2 hours, right? So you created a job. Under that job, your pod got started, and ideally backup process started, and ideally it should finish it in a 2 hours. But then due to some reason, your backup process got stuck, and that's not finished in a 2 hours. So just to avoid a load on our Kubernetes cluster, we can just simply define some deadline here, maybe let's say 2 hour, 10 minutes, because ideally we expect that job should finish in a 2 hours, but we are giving some 10-minute extra buffer. But within that 10 minutes also, if your job is not finishing, then there must be something wrong. So that's where we can define this active deadline second, so that even if the job is not finished within that, it will get terminated, so that we'll just avoid run into some different problem. Okay, so we can define this active deadline second as per our need. Then we have a backup limit. Okay, so this is again a very important attribute in a job. What it does, when under the job, when we create a pod, due to some reason, if that pod gets failed, right? So this backup limit specifies how, okay, or when you want to restart the pod if there is any failure, or how many times you want to do that. So by default value is 6. That means if there is a failure, it will try to restart for as far as 6 number. Okay, but if it is still happening, then it will just keep it as is. Okay, it will not go ahead and just keep restarting. Okay, then we have some important attribute like completions. Let's say you want to run this backup job, let's say 2 times, 5 times. So whatever that, by default, it's a 1. So you can go ahead and just define it, how many times you want to run it. Okay. Then we have something called as a parallelism, right? For example, you want to run the backup job 10 times, and then each backup process takes 2 hours. So that means it will take overall 20 hours, right? But by default, it happens sequentially, so it will take 20 hours. But if you don't want to happen, if you want to run it parallelly, so maybe you can specify, let's say, parallelism as a 3. So in that case, 3 backup job will run it at one go. And then it will like 3, 3, 3, and then finally 1. So this way, 10 times your job will get run. Okay, that will reduce the time required. Okay. And then there are some other attributes which are basically kind of just how after your job is finished, after how much time you want to remove it from the system. So that is something you can define it. Okay. So let's go ahead and create a job. So first of all, you can just check kubectl get jobs. So this will show you the jobs here. So right now there is no job, or even you can just do kubectl get all. So that will list out all the job, the pod gets created and set it, everything. So right now we don't have anything. So it's not showing. Okay, even I can use the watch as well just to see if it is happening as expected. Okay, so I'm doing a control C here, and let's create a job. So kubectl apply -f. Let me type kubectl apply -f job.yaml. So it got created. Let's add a watch here. So watch kubectl get all. So here you can see a job got created. Under that job, the pod got created and it is running. It will run for 10 seconds because that's what we have done here in our So it's a slipped in second, but actually there you'll have a job, backup job running. So you can see it's completed and now completion is done. So now it is not creating anymore. Okay, so that's how simply your job will work. Okay, now if you want to run this multiple times, very simple. What we can do is, let me just delete this pod, kubectl, delete the job, my job. Let me modify this job.yaml by adding the completions. So let's say I add a completions as, let's say, 3. Okay, and then we can also add the parallelism. Okay, where I just say parallelism as a 2. So in this case, what will happen? 2 jobs will run parallelly. Okay, so let me just specify it and run this. Okay, so yeah, it's a spelling mistake. I have to use the parallelism. I think that's where I'm making a mistake. Let me just verify it. Yeah, it's a parallelism. So let's open this. Okay, now let's try to apply. So you can see it got created. Let's watch, add the watch. So you can see job got created under that 2 pod got created. They will run it. Once that is done, one more gets created. Now that means there are 2 parallels created. Here you can see completion 3. So now 2 completions are done. Now the third one is running. So that once that is also done, we are done. So that's how simply your job will run. Okay, so you can run any kind of like backup job, cleanup job, batch processing. So that kind of application you can run through the job, right? So let's say this same job you want to run it on a periodic basis. Okay, so let's say you want to run it now. Just to quickly check it, what we can do is we can run it every minute. Okay, so for that, first of all, we need to create the cron job. So how to create a cron job? I'll just use the same command with little changes. So kubectl create cron job, CJ is the short name. I'll give the name as my CJ. Everything will remain same. Only thing that will change is we have to add the hyphen schedule. Okay, so hyphen schedule, where I can specify the schedule as */1 star and star. Okay, so basically this is a 5-star format. Okay, where each star represents a specific thing. Okay, you can find that details on the crontab.guru website. Okay, where you can just play around like how to define the schedule. So here this particular schedule specifies that, okay, we want to run the job every minute. Okay, so let me just store this into a cronjob.yaml. Okay, so it's got created. Let me open this. So you can see this is how YAML looks like. You can see the job component name is cron job. So this spec is a cron job specification. This spec is your job spec, and this spec is your pod spec. Okay, so let's go ahead and just create it. So kubectl apply -f cronjob.yaml. So it got created. Let's add a watch. So right now you can see cron job got created. Time is 6:58. As soon as 6:59 happens, you will see a job gets created, and under that job, one pod gets created. Okay, so let's wait for it to happen. Just keep an eye on this time. So still 6:58. As soon as 6:59 happens, you will see that a new job gets created, and under that job, a pod gets created. And that will keep happening every minute. Okay, but let's wait for the first occurrence of the job trigger. Just still 58. It should happen now 69 soon. So as soon as it happens 69, we can basically see that the new job gets triggered. Yeah, 6:59 is done. You can see a job got created. Under that job, pod got created. It is running. So it will complete whatever the task is given, like backup, cleanup, batch processing. And once that is done, it should be in a completed state. Yeah, here we go. And we have a completion. Okay, so that's how simply Kubernetes job and cron job objects will work. Okay, and they are very useful. So I hope everyone understood the concept. If you have any question, please do write it in a comment. If you like the video, if you are not subscribed the channel yet, please do like, share, and subscribe. Okay, so that's it for this video. Thanks everyone.